This is example 4 on page 170. We're talking about the commutative property of matrices. So when we're just doing algebraic expressions and equations, when you multiply two numbers, it doesn't matter which order you multiply them in. But in matrices, it does matter because of the rule of figuring out if they can be multiplied together. So we have two matrices. We have P, which has 3 rows and 2 columns. So it's a 3 by 2. And we have matrix Q, which has 2 rows and 3 columns. So what is it going to look like when we multiply these together? So first let's look at P times Q. What's that going to equal? So P is a 3 by 2 and Q is a 2 by 3. So first let's look at the inner. So the inner is a 2 by 2. So yes, that checks. We can multiply it. But then let's look at our outer numbers. We have a 3 and we have a 3 as our outer dimensions. So our answer is going to be a 3 by 3. So we'll have 3 rows and 3 columns. Now, let's look to see what happens if we use the commutative property and we multiply Q times P. So this time we're going to be multiplying, having Q first. So Q is a 2 by 3 and P is a 3 by 2. So let's check it out. Looking at the inner numbers, we have a 3 and a 3. Okay, it checks, so we can multiply it together. But let's look at our outer. We have a 2 and a 2. So our answer matrix is going to have 2 rows, 2 columns, which is completely different than a 3 by 3. So when you're doing the commutative property, when you multiply matrices, it's important to make sure you multiply them in the proper order. Because using the commutative, where you switch them, you will get a completely different answer. Okay, this is page 170, and in the Braille book it's about on page C170, about halfway down. So this time we're going to be multiplying three matrices together, but we're using this distributive property. So we have matrix A, which equals, row 1 is 3 and 2, and row 2 is -1 and 4. Matrix B, which is, again, 2 rows, 2 columns. So we have -2 and 5 as the first row, and 6 and 7 as our second row. And matrix C is also a 2 by 2. So we have the first row of 1 and 1, second row of -5 and 3. Okay, and what we're asked to do is we have A, open paren, B plus C. And so we know when we're multiplying, we have this A outside of the parentheses. We have to distribute that to everything inside the parentheses. But first, let's look and see what's happening on the inside. So let's write these matrices out. So we have A, so we have first row of 3 and 2, second row of -1 and 4, and then inside of parentheses, we have matrix B, which is -2 and 5, and we have 6 and 7 as the second row. And to that, we need to add matrix C, which is first row of 1 and 1, second row of -5 and 8, in close parentheses. So inside the parentheses, we can add these before we multiply it to the A outside the parentheses. So the first thing we're going to do is add these two matrices of B and C together. So let's take care of that first. So we have -2 and 5 as our first row, and 6 and 7, plus matrix 2, which is 1 and 1 for the first row, and -5 and 3 as our second. So we just need to add the corresponding elements. So first row, we have -2 plus 1, which gives us -1 for our first element. Then we have 5, then we have second element of the first row is 5 plus 1, or 6. And then the second row, we have first element is 6 plus -5, which gives us a 1. And second element of the second row is 7 plus 3, or 10. Okay, so now we have first row -1 and 6, second row 1 and 10. To this, then we can multiply A. So now we have, open matrix, 3, 2, first row, -1 and 4, second row, times -1 and 6, second row is 1 and 10. Now let's look at the multiplication of our two matrices. So we have a 2 by 2 times a 2 by 2. Well, so our answer matrix is going to be a 2 by 2. So this equals a 2 by 2. So again, we need to multiply the columns by the rows. So we have first column of matrix A times the first row of the second matrix, the one we added together. So we have 3 times -1 plus, I'm going to erase this second bracket, it's not big enough, so I'll redraw that in a moment, plus 2 times 1, which is just 2. And now the second element of the first row is again first row, second column. So we have 3 times 6 plus 2 times 10. Close up the bracket. Now for the second row, we use the second row of the first matrix times each of the columns of the second matrix. So we have -1 times -1 plus 4 times 1. And then the second element of the second row is -1 times 6 plus 4 times 10. And the last step is to simplify these. So the first element is 3 times -1 plus 2 times 1, which becomes -1. Second element is 3 times 6 plus 2 times 10, which gives us 38. And the second row, we have -1 times -1 plus 4 times 1 gives us 5. And then the last element, second row, is -1 times 6 plus 4 times 10, which gives us a -34. So their answer to our matrix, our multiplication of this matrices, is -1 and 38 for the first row, and 5 and 34 for our second row.